And we're live. Welcome everyone to another episode of React Native Live. It's great to see you all that are logging on now for episode 8. While we wait for people to kind of sign on, go ahead and let us know where you're coming in from. As always, I'm Mazen. I live in Durham, North Carolina. And yeah, I'll be your host for today. I'm excited to have Marc Rousavy on the show with us. Marc, how are you?
Hey guys, yeah, I'm great. How are you? Thank you for having me.
Yeah. Where are you signing in from?
I'm from Vienna. I'm signing in from Vienna. It's 6 p.m. right now. It's dark outside already, like the entire winter time.
Nice.
Yeah.
Nice. Yeah. Well, Marc is the CEO of Margello and also author of many great libraries that we probably all use day to day. We have React Native MMKV, React Native Vision Camera, React Native Blur Hash. There's many more, I'm sure.
Yeah.
But we're here to mainly talk about Nitro, and that's kind of what we'll dig into a little bit later. But I guess, Marc, tell me a little bit about yourself. Introduce yourself to our audience and just let us know, where, how you got to where you're at now as CEO of Margello.
Yeah, sure. So funny because you mentioned the libraries. I just 2 hours ago I just randomly checked the downloads because I never really checked the downloads of the libraries, and I saw that React Native Vision Camera had 25 million downloads and React Native MMKV almost like 35 million downloads ever since it was released, which is a lot.
Yeah, that's awesome.
Yeah. So, anyways, I'm Marc. I guess I'm a React Native developer, and I started working with React Native about 5 years ago. And I've been part of many different companies. I joined some startups here and there, helped out, a few companies as like a consultant. And ever since then, I just love doing open source, especially camera stuff. So that's why I do a lot of like real-time vision stuff. That's why I built Vision Camera and the whole frame processing architecture. And all of that kind of also influenced Nitro in a way, because for this real-time processing architecture, we need a super solid and performant foundation. So yeah, everything kind of revolved around that. I built an agency. We have, we're quite big already. The agency's name is Margello. Maybe you've heard of us. And yeah.
Yeah, no, that's awesome. I think we've talked about it. You've been on React Native Radio quite a bit. And I remember when we had you on for a rewrite of Vision Camera. Let's kind of stick to that topic. You mentioned that you helped Snapchat kind of get their initial feature up and off the ground. Am I remembering that correct?
Snapchat. No, it was not Snapchat. Snapchat does not use React Native. Maybe you're mixing it up with the Snapchat trick we talked about, where
Yes.
Snapchat.
That's what it was.
Where we kind of did some reverse engineering on a Snapchat app to figure out how they're using the camera, and it varied a lot between versions. Where some versions used AR Core or AR Kit or something. Then there were some versions where they actually took screenshots instead of photos to make capture faster on Android. So all kinds of tricks.
Yeah. Okay. Cool. Yeah.
But yeah,
I do remember you mentioning something about taking
that,
screenshots to kind of make it quicker processing,
yeah.
and how Vision Camera can kind of alleviate that and kind of make it easier.
Yeah. So in Vision Camera, you can also do that optionally, or just take a photo.
Yeah. Nice. So to our audience, as you're signing on, people are logging in, we're going to give you a couple minutes, grab coffee, grab a drink, wherever you are on this planet. Feel free to ask questions. Feel free to let us know where you're logging in from. While Marc and I kind of continue to chat here for it. One thing I want to ask you about, Marc, is your hobby of cars, right? I hear you like cars. Is it just looking at cars or racing cars, or what is it?
It's racing cars. So I don't know. I always kind of loved driving fast cars and getting more into racing. And it's obviously a very tricky hobby because it's super expensive and also time consuming, and also you kind of need some sort of skill to do it. I'm sure there's a lot of people.
Oh, I think we lost your mic.
Oh, my. I think my mic just.
There you go. Oh, again.
Okay. Probably shouldn't touch the cable here. Okay. So.
Oh.
Why is it disconnecting? Sorry, give me a second.
Now it's on a different microphone, I think. Technical difficulties. But yeah, while Mark is going, please. What is happening? There we go. Okay.
Okay.
We good?
Is it? I think we're good again.
Yeah, we're good.
Okay. Let's hope it stays that way. I think my driver just decided to do an update, but I'm looking at the icon right now and it seems to be stable now.
Yeah.
Just let me know
Perfect,
if it disconnects again.
Your OS decides to just restart it.
Yeah, drivers. So yeah, racing. I've been doing some. I wanted to get my cup racing license this year, which is super time consuming and expensive as well. And also I've been doing some drifting stuff and some just track days.
Yeah, I saw you post some stuff over the holidays. I was like, oh, this seems pretty cool.
Yeah.
What's your favorite car?
Oh, that's a tricky question. I would say the best all-rounder car in like a realistic price range, like some kind of realistic dream car, is a BMW M4, because it just it does everything so well. And if you kind of go more into like so there's the best car for every situation, for rally, for off-roading, for drifting. I would say a Mitsubishi Evo. For everyday driving, or like the perfect balance between comfort and sport, it's an M4. And for racing, I would say it's some kind of McLaren, maybe a 720, or some kind of Ferrari, maybe the newer ones.
Yeah.
Depends on what you're trying to do, I guess.
So I guess Gant was close by saying Toyota. I wonder if it was talking about Toyota Camry or Civic. I'm not exactly sure, but probably gets the job done.
Civic is a Honda, but yeah.
Oh yeah, shows you how much I know about cars there.
It's funny, every time I'm in the US, it's funny how different the cars are compared to Europe, because in the US people are always super excited to drive foreign cars, like European cars. Everybody wants to drive a BMW or an Audi, and here it's just a standard. Have that many Civics or Toyotas or whatever around, except for the taxis, I guess. But
yeah, and even cars like I know like Toyota Highlander is different here in the US as it is in Europe. Completely different engineering, setup, look and feel, and even size, I believe. I guess has to do with regulations or something. But anyways, we're not here to talk about cars. Sorry, Mark. Maybe next time. But yeah, audience, please keep the chat going. And as we're going, ask questions to Mark about Nitro, and we can kind of keep building on that here within the topic. I want to kind of start shifting towards our topic of Nitro. Over the years, our listeners on React Native Radio have asked us to get a little more technical when it comes to our topic, right? So this is kind of like a perfect episode, because just last week, so January 23rd, React Native Radio released Transforming Packages with Nitro, where we, Robin and I had you on the show. We talked about everything and anything Nitro without getting very technical, right? We just kind of talked about it in general, what is Nitro, who can benefit from Nitro. And now we get to kind of dig deeper into it and get a little more technical and kind of see it in action, which I think, the visual aspect of this is great. So can you go ahead and please give us the elevator pitch for Nitro? While Jamin wants us to build React Native CarPlay Nitro right now.
So depends on how long the elevator ride is, but usually I would say if you want to build a native module for React Native and you want to do more than just a simple static function or different static functions, you would probably be better off using Nitro. It's not always about performance or making something faster or whatever, because at the end of the day, the method call for from JavaScript to native, it's super, super fast. So unless you're doing like this in a very hot path in like million or thousands of times per second, I guess, you're not going to actually provide a difference to your users. Again, also you have to benchmark this. If it's like a super slow Android device, maybe a few less calls can also make a difference, but still. So for a simple module that just does one thing and you call it once or twice in the app, there's no real reason to use Nitro, unless if you prefer the APIs or are used to it or already have Nitro in your app. But then for anything advanced, anything more powerful, anything where you have in-memory objects, or you have special types that need to be bridged across languages, the default system like Turbo Modules does not support, then Nitro could be your choice, especially if you have mixed languages as well. So we have, most of our libraries have mixed C++ and Kotlin or Swift. And then it's just night and day difference if Nitro generates all those bindings for you versus you having to write all of them yourself, JNI, Objective-C bridges and stuff like that.
Yeah. Okay. Yeah. Cool. And I think, one other kind of building on that elevator ride, as developers, we tend to
It's a long-ass elevator.
Yeah. Well, we're going to like the 50th floor or something.
Okay, that makes sense. Yeah.
Yeah. We're in New York, I guess.
We're in the Burj Khalifa.
There you go. As a developer, sometimes we hit something that gets difficult for us to do, so we build a tool. And I assume Nitro was kind of one of those situations where you hit something really hard. Talk us through that and why it solved that use case for you.
Mm-hmm. I mean, I still, most of the libraries I built were originally Turbo Modules. So in the beginning, I did use Turbo Modules for most of my stuff. Sorry, native modules actually, before Turbo Modules were around. So Vision Camera, for example, is like still today, the stable version is still a normal native Turbo Module. And then Blur Hash or other kinds of modules I built are all native modules or were native modules. But we started hitting more and more limitations with the module system. For example, for Vision Camera, the most important or the biggest blocker was that you couldn't synchronously call a function from native, a JS function from native, and that's something that we required for a frame processor to be able to run in real time and pass a frame across. That's the second problem. So if you wanted to pass a frame, an in-memory instance of like a GPU buffer from native to JS, there was no way to reflect this using or to represent this using native or Turbo Modules, because you could only pass around primitives or like maps or arrays, but not a complex type. Think of it like a JS class with some private stuff. So those were the two main blockers for Vision Camera, not being able to synchronously call something because everything was either an event from native to JS or an async dispatch from JS to native. And then also for Filament, for example, we built everything using C++, because Filament is a C++ library, and there was no good support for C++ in native modules. So back then we started using JSI, and Turbo Modules weren't ready back then. I'm sure Turbo Modules have improved a lot since then. I think the C++ API of Turbo Modules is actually quite modern. But back then we couldn't use native modules or Turbo Modules for Filament. So we invented our own system that implemented this kind of conversion class in C++. It was a C++ template where a C++ class could be converted to JavaScript and back. And by having this in our code base, we could extend it with any custom type. So think of it like, if you pass a string, we just convert it to a JS string. But if you pass a C++ class that we defined and it's like a complex type, we can store a native handle called native state or a JSI host object on it and pass it to JS. And when we get it back, we can read that value again. So in a sense, it's shared memory. We also had support for array buffers back then. And functions or callbacks were also first-class citizens. So there was no event system. It was all just synchronous functions. And yeah, that actually, we needed that for Filament. There was no other way to build Filament. And so then we ported it into a separate library and made it available for everyone. And now I migrated React Native MMKV to Nitro. Jacek also built Unistyles and Uniwind on Nitro. And now I'm working on Vision Camera V5 on Nitro, which is also a complete rewrite again, because like all of the fundamentals have changed, and I can be much more flexible with the API.
Yeah, it seems like you like rewrite. I think
Yeah.
Jamin asked the question: do you use any AI coding tools, or do you prefer traditional coding with all these rewrites that you're doing?
No, I don't use any AI while coding unless I do have I do use ChatGPT from time to time if I use some new APIs, or if I have to understand some like fundamental things about some topics I haven't seen yet or used yet. But for coding, I don't use any AI. I feel like it's very disruptive and kind of annoying. The only thing I need is IntelliSense, obviously. But yeah, AI is. I feel like for the stuff I'm doing, where it's mostly a lot of API design and like new stuff, like I'm building a new library for users to consume. And AI, if you think about it, is just a big model trained on existing data, on existing APIs. But I want to create a new API that is maybe fundamentally different or groundbreaking or whatever. API cannot reasonably give me a good new API design if all it knows is the current existing API designs,
Yeah. So Jamin, Mark is the AI. So, well, Panic at Production asked the question, which I kind of really like. I want to kind of build on it. What makes Nitro Modules special? Is it faster than Turbo and Expo modules? What is behind the scene? And kind of building on that, what's the main difference between all three of them?
Yeah, so it is faster if you compare method calls, right? If you compare conversion calls, then it is faster than both of those. But the main difference is, I would say, API and ergonomics, and also the fundamental approach of. So there's two fundamental concepts in Nitro. Actually, three. I would say there's three fundamental concepts in Nitro. First is everything is a hybrid object. And a hybrid object is essentially just a JS object. You can use it from JS, but it has native state. So there's state, it's stateful on the native side in the C++, Swift, or Kotlin side. And if you call a method on it, it calls that method on that state. So if you have two different objects, they have two different states, right? It's what you expect from a JS class. If you do new whatever your class name is, and then again, new whatever your class name is, you have two separate stateful instances. And this is what Nitro is. But the only difference is to a JS class is that the state is on the native side and not on a JS side. So that's one fundamental thing of Nitro. And this is powerful because we can make images or frames in Vision Camera or MMKV instances one hybrid object. And you can have multiple of those and they're stateful. This is super powerful because before, a lot of the native modules used something like, IDs or whatever to refer to each other. We've seen like for views, you've seen native ID, and then for Blob, for example, Blob was implemented like this for a long time. I'm not sure if they changed it already, but Blob was simply a native map or registry where it stores an ID to a Blob instance, and when you call a method on Blob, it's a static method, and it resolves the Blob instance through the ID, which is kind of messy and it's loosely coupled because it could go stale, and then the reference just remains in there because it's not deleted or whatever.
It's still there.
Right. The second thing is, in Nitro, everything is super type safe. I love types. I never got used to writing untyped JS code. It's always TypeScript for me and as strict as possible, because then you just don't make any mistakes, right? If your TypeScript rule is super strict and you don't use any, there's no way to make mistakes. Typing mistakes, that is. So everything is typed, which means you write TypeScript types first, and then Nitrogen, the generator for Nitro modules, generates native specs. So that's C++ classes, Swift protocols, and Kotlin interfaces according to those types, and you have to conform to those. So there's no way that a native module or a Nitro module can return something else than what the TypeScript type says it returns, which is super, super cool and safe, because if the function says it returns a double or a number, there's no way it can return undefined unless it says it returns a number or undefined. So this is obviously super, super cool for safety. And the third one is everything is or I guess, yeah, every object in JS is a first-class citizen, including functions, which means you can pass array buffers, you can pass hybrid objects, and you can pass functions from JavaScript to native code. So whereas native modules, and I think also expo modules, but I'm not 100% sure on that, when they have an event emitter system where you just pass a function and then schedule an event emitter on the native side, in Nitro it's different. You just pass a function and then you get the function on the native side as a function reference, and you can just call it directly, which calls the JS function. So it's closer to how a JS class works, by making functions first-class citizens as well.
Yeah. And so, okay. So you've kind of given us all these pros, and I'm all about types. I saw a JavaScript repo recently, and I honestly didn't know how to read it because it was like, what are your types? What is this trying to reference? What is it trying to do? So when does it make sense not to use Nitro modules? And what use cases would you say that, hey, just use turbo modules or use expo modules per se?
I would say if your app does not yet have a Nitro module installed, and you simply want to have one function or two functions exposed that don't need to have any state. They're not stateful. They're just static functions like get current battery percentage, right? And you don't have Nitro modules installed, then just write a turbo module. It's much simpler. Or if you're in Expo, just write an Expo module. It's much simpler instead of just installing or creating a new Nitro module, installing it, generating the specs, and then implementing it. If for simple things, turbo modules or expo modules, probably most likely expo modules because the API is super nice, is nicer. Also, I think in expo modules prototyping is much quicker, because if you just want to expose this battery percentage method to JavaScript, you just write it in an expo module and then it gets exposed through expo modules registry or whatever. There's no types in expo modules, so you have to kind of slap the types on yourself. But for prototyping, it's much faster than Nitro modules. So Nitro modules is more for like, okay, you want to ship something and it needs to be, like a, I guess if it needs to be stateful and if it needs to be, if you need some certain types that are not supported in Turbo, then you should probably use Nitro. Otherwise, you can,
Yeah, no, that makes sense. And Jamin kind of asks a good question, or
array
asks
buffers.
to clarify on array buffers. Yeah, can you explain that a little bit more?
So an array buffer is shared memory between JavaScript and native. So when you have, let's say you have a simple number array in JavaScript. It's an array of numbers. A number is 64-bit. It's a double in JavaScript. So when you pass it to native, and let's say it's like 1,000 numbers, you have to iterate over the array and copy all 1,000 numbers into native code, and then you have the 1,000 numbers in native code. And then if you want to modify it, you have to modify. You have to copy it to an array first, and then modify it on a native side, and then return a new array from native. You can also theoretically modify the array directly from native code, but it requires you to be on the JS thread, and you cannot do it from a different thread, and so on. So arrays are kind of unergonomic when you cross the language boundary, whereas an array buffer is actually shared memory. So you actually can have the same memory address, or you can access the same memory address and write to it and read from it in both JavaScript and native code. Which means when I pass an array buffer of a lot of numbers, it doesn't matter what it holds. It can also hold numbers, right? You can also hold doubles, 64-bit doubles. So when you pass an array of numbers onto the native to the native side, you can get it as an array buffer, shared memory, write to it, and just that's it. It's part of the array buffer now. You don't have to do any copies. So array buffers are this super useful tool, and not just useful, it's actually required if you want to pass a lot of data between JS and native. So for example, in Vision Camera, when you have a GPU frame, let's say it's in 4K, let's say it's RGB, and you're streaming it at 60 times per second. Then you're streaming, I think, 1 gigabyte or something per second of bandwidth which is a lot of data, right?
Mm-hmm.
And if you copy the data of each frame, every frame you see into JS, that's a lot of copies. That's a lot of memory copies. That's 1 GB per second of memory copies. So what I do instead is I use the existing buffer of the GPU frame, which is, what is one frame? Like 15, 20 megabytes, 30 megabytes, something like this. I use the existing buffer, wrap it around an array, wrap an array buffer around the existing buffer, and then pass it to JS. And it's still the same memory. There's no copies here. I just pass the array buffer to JS, and JS can read the memory. And when it's done, it's done.
Yeah.
So it's, I'm not sure if I explained it very well, but it's, in a sense, it's zero copy data.
Exactly. And it's more performant, right? You explained it great, because it's
the only reason you need it is performance. Yes.
Right. Exactly. Yeah. And without, like you mentioned at the beginning, if it's not an array buffer, you're having to copy it, write to it, do whatever you need to do, and then send it. And you're sending it as something completely different back over to the JavaScript side. So I think that's perfect. Performance-wise, it's key to use within here. I love all these questions that we're getting. We're going to get to the demo at some point. Again, you mentioned it earlier, right? Like, don't use Nitro if you don't have a Nitro package already within there. So MMKV, Unistyles, whatever it may be. What are the biggest challenges when adopting Nitro in a mature React Native code base? So I have a code base that doesn't have Nitro, but I want to adopt it because, I'm adding in some more packages, or I even need to get a Nitro module in.
So I would say the biggest challenge first is making sure that your setup is correct. So you need, so Nitro is fairly recent and it uses a lot of newer APIs in React Native, in Swift. Nitro uses the Swift, a new Swift compiler feature, which is the direct C++ interop. It uses, so it can actually call C++ methods, and C++ can actually call Swift methods directly without going through Objective-C, which is much faster as it's static dispatch and not virtual dispatch. And that feature has just been recently released. So the first challenge you're facing is upgrading all your stuff to the latest versions. So Xcode needs to be on Xcode 16.4, I think. It's not the latest version. The latest one is 26 point something. But there's still people who are not on 16 yet for some reason, or on 16.4. I think Nitro would not build on 16.3. Then what else do you need? Fairly recent React Native version. I think if you want to use Nitro views, you have to be on React Native 0.79 or something, or 80, something like this. We're on 84 already. I think it's a fair minimum requirement.
Yeah, it is.
But still, that's something you have to keep in mind. The second thing is, in terms of challenges, if you install a Nitro module, there's no real challenge, right? You can just install it and install React Native Nitro modules, the core runtime, and then your Nitro module, like React Native MMKV, UniWind, Unistyles, whatever. But if you want to build something, the challenge you're going to face is probably how to integrate it into your app. And I made a YouTube video about that, and we're going to take a look at this as well now. But some people don't understand that you have to create a separate local package for your Nitro module. You cannot just throw it all into your app's code. So it needs to be a separate package, and then you're going to install that local package into your app. So that's one other challenge, I would say. Yeah. And then the rest, I don't know, maybe learning the API. I think the docs are fairly good, although I've heard from some people that they are struggling with the docs because they're not always complete. So when I show code snippets, it's always just a snippet and never the full code. So there's no imports and no, I guess there's no imports. So some people kind of get confused with that. Other than that, I don't know. You tell me.
I mean, I built something with Nitro. I think I mentioned it to you earlier. I tried to do it using Expo modules and Nitro modules, and I kind of came to the same. It worked in Expo modules and it worked for me in Nitro. So I was able to kind of access it easily. And this was building off of maps specifically, right?
I think one challenge you're definitely going to face is that if you don't give AI LLM context, it's probably going to tell you bullshit. So because Nitro is fairly new, it's just a year, or a little bit more than a year, I guess. If you ask like any standard AI, like unless you're working at the CIA and already have access to the newer APIs, newer AIs, they probably have outdated information on, or just hallucinate stuff and mix turbo modules. And I've seen an AI tell me that Nitro Modules is a new module system that uses, Swift and C++ direct interrupt, and then it started generating Objective-C code. And I'm like, how do you, like, where's that coming from? So it's time to read some good old documentation again.
I want to just build on Panic at Production. Your question is writing Nitro more complex than other module approaches? For example, I want to add CarPlay support to my app. I mean, let me kind of go at it, Mark, and you tell me if I'm right. It's not necessarily more complex. It's same thing. If you haven't built one before, it's a new API system to learn, a new process to learn. But at the end of the day, you're still writing Swift, Kotlin, or even C++ code. So as long as you have that part there, the bindings or the way it's bound to your React Native app is really the difference between a Nitro and a Expo module app. Right? Would you add anything to that?
I agree. I mean, the bindings are depending on how big your API surface is, but most probably the bindings are not the thing you spend the most time with. And I think that's what, in Nitro, I try to make it as seamless as possible. And also, I try to make it as close as possible to just writing JS code, to just writing a JS class. So when something is an async method, it's not magically running on an async thread, but instead you have to return a promise, just like in JS, right? So then you return a promise, you have to resolve and reject, or you do promise.async, which is a wrapper for Swift async or Swift or Kotlin async. Same for callbacks. They're not magically some events or event listeners or IDs or whatever, but they're just functions. So it tries to be as close to a JS class as possible.
Yeah, awesome. So while we're talking about languages, last question before we move into the demo. In the future, could it be possible to create native modules with Rust, similar to how they're created in C++?
I get this question a lot, and I haven't built it myself yet. I haven't built a Rust module in Nitro myself yet, and I've actually never used Rust before because I don't like the language. I like C++ more. And I feel like, so I've seen people use Rust with Nitro, and I feel like most of the people that ask this question haven't tried it themselves yet. Because at the end of the day, what you're doing is you're using the C++ API and then just bridging over to Rust yourself, which is, I agree, it's not first-class support because you're not using Rust types. Like, I think Rust has many different types for a string, and C++ SCD string is not one of them, obviously. But still, it's much easier to bridge yourself from C++ to Rust than it is from C++ to Kotlin or C++ to Swift. So that's why Nitro generated first-class support for that. But then for Rust, I don't have enough use cases to add true first-class support for that. So if you want to build a Rust module, there are some online. I've seen some. They just generate C++ code, and then in the C++ method implementation, they just forward it to the Rust implementation. There's also some limitations with Rust that need to be addressed. For example, I think you don't have inheritance in Rust, so everything is kind of like in Swift with a protocol witness table. So you have what is it called? Trait, I think, trait conformance, and Nitro has inheritance in all 4 languages. In JavaScript, obviously, through prototypes. In C++ through virtual base classes, and then in Swift and Kotlin as well. So Rust can't directly mirror that unless we figure out. I don't know if there's like runtime trait conformance in Rust. I've never used Rust. If that works, then we can mirror inheritance that way. Somehow it still needs to have a state that needs to be passed up so that, type erasure works, conditional downcasting and runtime works, even though the type is erased, and stuff like that. So very tricky challenges for making the whole test suite actually go through. It is definitely possible to add first-class support, but I think for now it's fine to just write the Rust bindings yourself.
Yeah, and I think, Robin actually brought it up. We spoke with Crane recently about React Native Node API. We're doing something similar to this. Rust would essentially kind of be the same thing within there. I know Node API has a fork of Hermes, if I'm not mistaken, to be able to get it to work. And that's kind of where things are a little bit, different for them. So I think all this like outside of C++, Kotlin, Swift right now, these are all experimental, and you almost have to be on the bleeding edge or even past that edge to be able to get it to work for the most part.
So Robin, I have a question for you. I haven't used Node API. Isn't Node API more of an alternative to JSI than it is to Turbo Modules? As in, you still get like a JS string as an argument and not like an STD string or a Swift string or a Kotlin string.
I believe you're right. We can wait for Robin to kind of answer the question, but I believe yes. Here we go. Green said one of his primary motivations was being able to write modules in Rust. So yes, it does open the door for modules to being written in Rust and other languages. So
because Node API has Rust bindings, or why is that?
Correct. Yes.
Okay.
Yeah. So what I urge listeners when they're talking about anything outside, so Rust or any other, to be able to write native modules in that sense, Crane has a talk that he gave, I believe, last year at React Universe Conf about Node API. Listen to that talk. And also React Native Radio will have an episode coming out soon regarding that. We have a bunch of other questions I'm going to ask along the way, Mark, but I think now would probably be a perfect time for us to kind of shift into our demo stage. So I'm going
to... Wait, Jamin had...
Tell me.
That's an interesting question, Jamin. I don't think it does that because you're not... maybe I'm wrong, but as far as I understand, Node API does not have an Objective-C API, right? So if you receive something in Objective-C, it's a node type. So a node string or JS string. It's not an NS string. Unless I'm mistaken, maybe Node API does actually provide you with platform native types. But then I wouldn't compare it to Nitro because Nitro gives you the platform native types. So if you pass a JS string to your Nitro module, you will get a Swift string, not a JS string, which makes a difference because you can use just the normal Swift string methods. And if you write something in Swift, you want to use a Swift string, not a JS string. But I haven't used it before, so I can't really speak on that, to be honest.
Well, let's move into the demo here. Let me kind of put your screen up a little bit here. So we're going to go over Nitro. I think you're going to show us a bunch of different things, Nitro modules, Nitro views, and kind of how all those kind of function within there. So go ahead.
Okay. Cool. So I'm going to excuse myself for my loud keyboard up front because it's going to get a little bit annoying, but I have a loud keyboard and I don't have any replacement here for the stream. So you got to live with it. What I did is I created a simple folder or Git repo with two projects in it. One is the Nitro module we're going to build. So this is like any library that you can ship to npm, and one is a simple React Native app that's going to use our local Nitro module.
Can you zoom in just one or two? Perfect.
Is that too big?
No, that's fine. I think some people, yeah. There we go. That's good. Go for it.
Okay. So this is the example app. This is a React Native app, and this is our React Native Nitro module that we're going to build. I called it React Native Nitro lib. And then our React Native app is going to depend on that and use that. So if we open that in VS Code, we're going to, okay, I can make that bigger, perfect. I created a Git folder for us to just track this. This is a standard React Native app. I created this using this command here, the React Native community command. I should really migrate to the expo command. I think it's probably time to do that. But it still works for me, and it's super fast to install. So I use the React Native community, which I think Callstack maintains. and then init, and I call it nitro lib example. And then for the nitro module, I used npx nitrogen init, which creates a new nitro module. And then what I did is I used bun to install the modules in both libraries. Then I generated the specs for the nitro module, which I wrote a simple example nitro module first, because if you generate the specs without an example module, it's going to tell you there's nothing to generate. And it's going to fail. So you need to write some kind of hybrid object. In my case, I call it example. It extends hybrid object, and then we have the platforms in here. This is the typical Nitro syntax. I'm going to explain it in a second, but what you need to know is example.nitro.ts, created that there, and then I ran bun specs in the lib folder, which is a command by the nitrogen template, or from the nitrogen template, which just generates the specs using nitrogen. I think I can remove that log level debug. I don't know why that's still in there, but you just need to run npx nitrogen in the root folder, and that's gonna read the nitro.json file, which is also generated in a template. So all of this is already there, right? Only the spec is something I wrote, but the nitro.json is there. It's going to, it's basically just defining your namespace and library name and whatever. If you plan on changing that, like for example, if you plan on changing the native library name for whatever reason, you also have to change it in your nitro.json. That's this here. But again, this is just generated and just works. So, and this is
just to recap, nitrogen is a command that you run that's going to generate all your native files for you.
Right. So yeah. So I wrote example.nitro.ts. Then I ran npx nitrogen, or bun specs is what I aliased it to. And what it generates is a nitrogen folder, or nitrogen/generated. And in here you can see different subfolders. You can see the shared folder, which contains all the C++ specs. You can see we called this example in TypeScript. So in C++, it's called hybrid example spec. So this is the naming convention Nitro uses. Example is the name from TypeScript. So if I change this, it's also going to change this part here. Hybrid is always a prefix because it's an instance that's living both in native and JS. So that's why it's called hybrid. And spec because it's not the implementation, but the specification. So there's no implementation in here, and you have to implement this later. But you usually don't have to worry about the nitrogen generated files. Then you also have iOS files, which, because this hybrid object is in C++ right now, just set up auto-linking. So I think this is all empty. Yeah. Right.
Because there's no functions within there right now.
Right. And this is the extension for the pod spec, just to make sure that everything is enabled, like the Swift interrupt mode. It's using C++ 20. If that's a blocker for you, then it's time to upgrade. And then the same for Android as well. So the onload function here just loads this native C++ stuff. You don't have to worry about that stuff, and I don't want to get in depth here because it's native stuff and it's generated code. What you need to worry about is installing the library then in your example app, which is what I did. So in package.json, I ran bun add, and I installed React Native Nitro lib, which is the thing we have here locally. So that's /React Native Nitro lib because it's a local module. And then also you need to install React Native Nitro Modules, the runtime library. This contains the C++ code that you need at runtime. So this is super lightweight, but you need it. And then you also need to make sure that you're on the same version. Maybe a bit of explanation about the versions, because I received a lot of questions around versioning. In your Nitro library, in React Native Nitro lib, in this library, we use, where is it? Where's Nitro?
65.
It's on star. Why is it on star? That's not a good idea. That should be an actual version. So what you do is you pin it to a version like this. And the version you pinned this to is obviously the version that your specs target, right? So if you have nitrogen on 0.33.5, you also need to have your runtime at least 0.33.5. But if you upgrade the run, or if you install this Nitro module, these specs were generated on 33.5. But if I install this library here in my app, in my whatever app, and I use a newer version of Nitro modules, like 0.6 or 0.9 or even 34.0 or whatever, it will still work for the runtime library because the runtime library is backwards compatible. What won't work is if you install a Nitro module that was built on an older Nitro version, like on a newer Nitro version. My bad, I got confused myself now. And then you install an older Nitro modules version here. So if you install in your app, you install 0.33.0, but the library was built on 33.5. It might be using newer APIs that were not yet available in the runtime version. So the runtime version, the React Native Nitro modules package, needs to be at least, or the version needs to be up to date with what all your packages are using, or newer.
Yeah. Hopefully, if you have more than one package, like you have MMKV and then Nitro and then Unistyles and something else, hopefully they're all aligned on the version also, because that could also pose an issue if one is
it shouldn't because it should be fine because it's because the core library is backwards compatible. So you just need to be like a common you just try to make sure that this one is always the newest version.
Yes, always upgrade. Got it. Okay.
Always upgrade this. Right. Okay, cool. So I'm going to go over the syntax here real quick. So nitrogen will generate, I can actually show you how this looks like. So if I go into this folder and run, if I run on specs, this is what the nitrogen output is going to look like. Let's see if I can also do npx nitrogen. Yeah, it's the same story here. So this is what the output is always going to look like. Nitrogen is loading your nitro.json config. Then it's going to tell you the version of nitrogen, the folder, and then it's going to tell you what specs it found. So in our case, we found one spec in source/specs, which is example.nitro.ts here. And then it's going to start parsing that. As you can see here, it's going to generate the specs for the hybrid object called example. And then here it's going to generate the C++ code. And then it's just going to do auto-linking stuff. And then there's a summary here as well. So if I rename this, or if I have multiple objects here, it's obviously going to give us multiple objects in here. But what we need to worry about is the spec definition. So for the simple module, I always use it as an example. It's called math. You always write export interface math extends hybrid object, and then here you have this generic object clause, whatever, arguments where you can pass the the languages of your hybrid object, which is the language that you're going to implement it in. So you choose at this point in time, am I going to implement it on iOS or on Android? In Swift or in C++, right? Mm-hmm. So on iOS, you choose Swift or C++. There's you have to do one of those, obviously. So you have to pick one of C++ or Swift. And then you can optionally also implement Android and vice versa. You can also only choose to implement one on one platform, right? You don't have to always do both platforms. Which is going to be relevant for the future when we have stuff like Windows or something here. Yeah. Right. So, okay, you choose the languages, you give it a name. The file has to have a .nitro.ts suffix. And right, so let's do Kotlin and Swift for now, because it's simpler to read. So we have, on iOS we use Swift, on Android we use Kotlin. What you can do now is to add methods and properties. So for example, if I have a method called add and it takes a number takes two numbers actually, and returns a number. This is the method syntax. Not to be confused with the property syntax. So if, let me do this. So those are two different things. This one is a method, and this one is a property that is a function, right? So some people get confused by that. Here it says method as well. I'm not sure, does this say property? Yeah, this says property. So those are two different things. You want this, obviously. You can also build this and it will still work, but it's going to be a property of the class and not a method of the class, which is going to be a bit weird to use. But anyways, we have this method here. And now if we generate the specs again, we can see it added the files for our class now, for math. And if we take a look at the generated files, so it tells you, by the way, it tells you added 9 files and remove 2 files. So you need to run pod install or sync Gradle again because the files changed.
So remove the C++ and brought in Swift and Kotlin.
I removed the C++, which removed 2 files. Then I brought in Swift and Kotlin, which added 2 files for the specs, 2 more files for the C++ implementations, and then some bridging and auto-linking stuff.
Yeah.
So if you want to take a look at the spec that you're going to implement, you can see here it's in Nitrogen generated and then iOS Swift or Android Kotlin. Let's take a look at Swift first. This is the protocol that you have to implement. It's called hybrid math spec. Ignore this part here. It's a bit ugly to implement in Swift because we cannot have virtual or abstract classes in Swift. So I have to add a protocol conformance and a base class and then combine it here into one thing at the bottom. Okay. So this is a bit of Swift magic here. But we need this to be able to do inheritance and type erasure and stuff like that. But what you need to worry about is simply this protocol, which you have to implement, which, as you can see, has no properties and one single method. It has the method add, which takes a double, or takes, sorry, 2 numbers and returns a number as well. So every number in JS is a double. There you can convert it to int or long or whatever yourself, but every number is a double. So I'm not doing any conversions for you because, you know, that could be biased. Like, what do I do if the number is out of range? What if it has commas? What if it, like, you know? Right. So the flow is always you open. Okay. The first thing I want to do. Actually, okay. So you're always going to work on your code, on your implementations in Xcode or Android Studio. I would not recommend writing all of this in VS Code. It's just super tricky to set up the imports properly. React Native uses a lot of like Cocoa Pods, Magic. It's going to change when we migrate to Swift package manager as well. It's super hard to just set up VS Code properly. So what you just want to do is just open it in Xcode and work from there. So before I open it in Xcode, I can just already create the file here on iOS. So we're going to implement iOS first, and I'm going to call it hybridmath.swift. Okay. So hybridmath.swift, we can close this. Hybridmath.swift will implement the hybridmath spec.swift. So the way I'm going to do it is class hybridmath spec. And this is all that I'm going to do in VS Code for now. This is just so that we have a file. What I'm going to do now is I'm going to go into our example, and I'm going to go into the iOS folder. Sorry, I need to do install here so that it copies the local library over again. Then I go into the iOS folder, and then I do pod install as well. Right. So that's installing.
So while that's installing, Tyler asked the question, do you have a preferred flow for developing Nitro modules alongside an example app? I assume it's always create an example app outside of your repo, or would you put it within the library?
I put it
repo?
within, yeah.
You'd put it within.
Yeah, so that's how I also do it for Vision Camera V5. You have, I can show this real quick maybe without showing too much code.
You get to see the magic, everyone.
So I have packages / React Native Vision Camera, and then there's also going to be packages slash maybe something else in the future, maybe like a Vision Camera resize plugin or Vision Camera worklets plugin or whatever. Right now, that's all in core, or a QR code scanner, for example. And then I have examples slash Vision Camera example simple, for example. I could also create a second example here called Vision Camera example, whatever, frame processing or whatever. So it's always under one repo for me because you're always going to work with a local package anyways.
Yeah.
It's just super annoying if you have two separate repos. So it should live in the same repo. And then in the example, for example, I use a bun mono repo. So the way it's linked here is the same as we saw before. Yeah. It's just, local file ref, whatever. Cool. So, okay, we did pod install. Pod installation is complete. Now we can open the example app in Xcode. So you're not going to open the library in Xcode, but you're going to open the example app in Xcode, which has everything installed. So in iOS, you're going to open the XC workspace. I already did that, and this is what it looks like. So on your left, you can see your apps code. You've probably seen that already.
Sorry.
I don't know if I can actually make that.
Oh, yeah, I forgot. Xcode can only, the left pane can't be zoomed in.
Okay, so this is gonna stay that small, but whatever. Let me make that full screen at least. I don't know. So you have your app first, and then you have a second item called pods. You're going to open pods. You're going to open development pods, and then you're going to open, in our case, Nitro lib. And then you can see, let me actually collapse that. And then you can actually see we have the iOS folder and the Nitrogen folder here. Nitrogen folder is just generated stuff. We already took a look at that. Here's the protocol again that we saw before. But what we need to worry about is the iOS folder, which just contains hybridmath.swift in our case. And there we go. Xcode is already telling us that the hybrid math class does not conform to our protocol. So this is super helpful because we can now just click apply here. And there we go. It's going to fill us in the add function. And all we need to do is now implement the code here. Make that even bigger. There we go. And all I need to do is return A plus B. And that's the implementation for add, which is super simple. Right. So now you have one implementation of hybrid math spec. But because Nitrogen is obviously object-oriented and there could be multiple implementations of hybrid math spec, we need to tell Nitrogen how to create an instance of hybrid math of hybrid math from JavaScript. So the way we do that is by auto-linking it to the Nitro Modules, like installed native or installed Nitro Modules, hybrid objects, whatever thingy. So there's a registry for that. And the way you do that is, because right now there's no way you can create this instance from JavaScript, right? You can still use it from native code, and you could theoretically get access to a JS runtime from your app's start function or whatever, and then inject that into the global. But the way Nitrogen's registry works is it's lazy, and it's caching the prototypes and everything. So it's smarter to install it using Nitrogen or Nitro's auto-linking system. And the way that works is you're going to open your nitro.json, and in your nitro.json you can see auto-linking here. It's an empty object right now. So what we need to do is we need to set up auto-linking for math. This is the name that we gave it, or you can give whatever name you want. You can call it like this. But typically you would use the same name that you also called your hybrid object, right? Yeah. So math is an object, and then you can provide it with implementations for each language. So in our case, we have one implementation in Swift. So the Swift implementation, and then it's a string again, and then you just use the same name as here. So in our case, hybrid math. If this was named something else, you also have to name this something else. Right, so this is hybrid math now. Then we need to actually open up a different terminal here. Then we need to go into the lib again and then generate specs again. So now it generated the auto-linking code for that. It added two files again. We need to do pod install again. Let's do pod install first so it copies over the lib. In a mono repo, you don't need to do that, by the way, because it's like linked. So then do pod install again, because we have 2 new files, which is, I don't know which files are new. Oh, these ones, nitro lib auto linking. Yeah. And as you can see, the code that got generated here is create math, which is going to create hybrid math here. So that's our implementation. And then some C++ stuff. Cool. So that was generated. And then now what we can do is we go into the JavaScript code, we go into our index file, and we can now create an instance of that. So we can call it math, and then you use Nitro Modules dot create hybrid object. You give it the type math and the name math. So what is this? Yeah, type. Okay. So now we can export the math instance in our index.ts file. Run install again. And if we go into our apps code now, this is app.tsx, we should be able to see math from nitrolib. Let's see, it's called something. Oh, I didn't do TypeScript again. What is it called? Bun TSC.
TSC.
And then bun install here again. Loading. Math. There we go. Okay, so we can now do const result is math.add 5 and 3, and then log that. Maybe to showcase this a bit. So math is a hybrid object, and a hybrid object has some base methods. So this is the method we created, add, but there's also a debug-only property called __type, which is, you can use it for debugging, but it's not used by Nitro at all, and it might be removed in the future as well. I don't know. I just added it for debugging. It's not part of it in release, obviously. There's a dispose method, which is something you probably shouldn't use, but there are certain cases where you want to use it, and it does more than just calling dispose on a native in a native method, because it also detaches the native state from the JS object and all that kind of stuff. So for a frame, for example, in Vision Camera, you will use dispose at the end of the frame processor. Then you have equals, which actually compares this hybrid object with another hybrid object for native equality. And then you have a name property, which is going to be just math in our case, and toString method. Anyways, so hybrid math.add 5 and 3, and we're going to console log, or actually let's not console log it, let's display it somewhere.
Put in a text string.
Yeah, let's do text. And then do result here. Do this. Let's hope that this is okay. Oops. Make sure that's centered.
Yeah.
Build the app, and we can ignore those imports here. Right. So now we call math in the render function and then display it. Let's wait until that builds.
So while that's building,
yeah,
is that going? Yeah, it is. Sorry. That was Swift and Kotlin, right? You can then, because we have it open in Xcode or Android Studio, you get access to all that stuff eventually. And you can kind of build whatever native module you want from there.
Yeah.
I'll let you take a look at that real quick.
Wait, why is that not resolving? Let's see. Maybe I just need to restart Metro. No, I don't. Unable to resolve module. That's interesting.
The live demo gods right there. Yeah, because it's right there. You have it.
It is right there, right?
Yeah.
You removed it again.
Pod install again? Probably not.
No, it's not. It's a Metro import. I don't know why it's failing, because it is part of the node modules here.
Mm-hmm.
So I don't get why it's not resolving. Oh, now it
There
works.
we go.
Okay. So what is it? 5 and 3 is 8. I think that's correct.
Mm-hmm. Not 53. Got it. Cool. Yeah. So Jamin had a question that I wanted to kind of bring up. You've used C++ a lot in building Nitro, and you mentioned Nitro, you mentioned before that you can build in C++. Now, for listeners, you probably can't build a module that requires something that's like maps, for example. Maps requires you to do it in Swift, and Kotlin can do it in C++. So there's like a limitation there right now.
Mm-hmm.
Back to Jim's question, do you like C++? And do you think React Native devs should learn C++? And, what are those scenarios that you would say use C++ over the native language?
So I think C++ is a love-hate relationship. C++ is a super, super powerful language. It's super fast, and you can basically do everything you want with C++. I mean, at the end of the day, everything you're working with is probably built in C++. JS, the JS runtime is built in C++. React Native is, Nitro is as well. So it's super powerful, and you can build some really amazing stuff with it. That's for example, C++ templates. Nitro is built on those templates. Maybe we can take a look at that as a quick showcase. So the JSI converter is one thing that's Nitro basically built around. You have a C++ template with a type T, and then you have the from JSI function and the to JSI function. And as you can see, from JSI takes a JSI value and returns a T, and T is whatever type you give it. And to JSI takes a T and returns you a JSI value. So you can extend this template with, for example, int, or let's take a look at double, simpler. With double, for example. So if we get a JSI value, we just convert it to a number, and that's going to be a double. And then the same thing here. And this grows increasingly complex, for example, for functions, maybe a bit too complex. So we have templates with a return type, then variadic type names for the arguments, and then the JSI converter is implemented for std function of the same return type with the variadic arguments. Then we have, and here's some really powerful stuff, an inline static const expression bool, which is something a JS developer probably has never heard. It's inline because it's I guess inline is not very important here. Const expression is important here. Const expression means that this type is evaluated at compile time and can be used to build stuff at compile time. So if you have an if statement here, if const expression is async, and then the if statement here is const expression, and there is async value here, which is a bool, by the way, just a normal boolean. Both of those are a const expression. So maybe take a look at what it does first. So it just checks if it is a promise, if the returning type is a promise, or if it is void. In this case, it's going to be an async function. And if that is the case, it's going to only compile this code here into your app. And this code here is not compiled at all. And on the other hand, if it is not async, it's only keeping this in your code, and this is going to be completely removed. And also, obviously, the whole if branching is going to be completely removed. So it's another unnecessary check that's going to be removed, right? So if you have a lot of those based on type inference, on reading, on understanding the types, you eliminate all of the cost of type checking and move it all to compile time. Whereas in JavaScript, you need to understand, or you need to do something like instance of promise, return type instance of promise, stuff like that. So this is what you would need to do in JavaScript. And even in Swift or Kotlin, you cannot do const expression branches. This is more powerful than preprocessor as well, because you can actually write C++ code in here. It's just, you can do so much stuff on type inference. And then the cool thing about the JSI converter is that since everybody's following along the type safety, so you have to conform to the types, otherwise you cannot implement the function. I know for sure which type I'm going to get. So if I get a JSI value from you, I don't have to do is number, is string, is object. I just know straight ahead it's gonna be a number. I'm going to cast it as a number, and if that fails, I'm just going to throw. There's no other situation for this specific function. So this is all the templates that are going to, bridge your types to JavaScript. So do I like C++? When it's 3 a.m. and my eyes are burning and I'm looking at this template here, and I'm trying to debug templates, and templates are, by the way, header files only, so there's no way to debug different variations of it. So it's kind of like you're on your own. There's also no compiler that is really going to tell you, hey, there's an error here, because it's a template. It's not, it doesn't know yet if there's going to be an error when it unfolds the template. So in that specific situation, I probably would say I hate C++. But once that feature is done and I ship it and I merge it, I would say I love C++, because it's just so powerful.
That makes sense. Cool. Should React Native devs like learn C++, or would you say there's still a lot of time ahead of us before, everything, like there's a lot of C++ development in React Native?
I don't think a React Native developer has to learn C++. I strongly disagree with that. In a sense, framework developers like me and like all of my other guys at Margelo, and some other guys that are maintaining libraries, you guys have some stuff too. If everybody has to learn C++, then we all failed in our jobs. So what we do is we build libraries so you don't have to use C++. So in a sense, you only need to learn C++ if you want to contribute to those libraries or build some of those libraries yourself. But usually in most React Native apps, and we have some people on our team as well that don't know C++, usually you write JavaScript and that it works, right? And if you know how to write good JavaScript, and if you understand some abstractions, and that's why we're here today, right? If you understand some abstractions more than just reading the docs and like some behind the scenes, if you are not afraid of taking a look at the code, then you can do more powerful stuff even in JavaScript without ever crossing languages than someone who just uses AI to generate code, or doesn't read the docs, or just uses stuff and doesn't worry about the fundamentals. And I'm talking specifically about the worklet stuff and re-renders, like hook dependencies, React memo, and stuff like that. So if you know how it works behind the scenes, you're automatically going to become a better developer.
Perfect. Great answer. Thank you. Do you have anything else to demo, just to make sure covered everything?
We can. So I probably don't want to show like Kotlin, because it's the same as Swift, right? It looks the same. And C++ is very similar as well. You're just going to write the C++ class and then override a method. What I can do real quick is to build a view. But
what is a view? How is a view different from a hybrid object?
Right. So a view is, let's do, what kind of view are we going to, like, let's call it red view. Okay. So a red view is going to be, it's been a while since I wrote a view, so let's see how this goes. Red view props. Oops, that was wrong. And then you have red view methods. Okay, so okay, I'm not getting good ideas here, but let's call it isRed, and then we have red view is a hybrid view of the red view props and the red view methods. I think that's correct, right?
That looks right to me.
Yeah, and then you have the platform specs. Okay, so views are a bit different in how you write them and how you use them than hybrid objects, but they are still hybrid objects. So a hybrid view, as you can see, it extends hybrid object. So, your view is going to be a hybrid object on the native side. The only difference is that it's renderable. So on the native side, you also have to conform to the view protocol, which just has a view property. So you have to just be able to render a view. And then also the difference in its specification is that you have to split out props and methods, because methods will be something that are going to be part of the ref, and props are going to be something that you can pass from JSX. Right? So,
and like you showed earlier, platform, you can also specify how you're going to write this in your platform.
So you can do like isRed true here, but if isRed is a method, obviously you cannot pass it here. right? Sorry, what did you say?
No, sorry, I was going to say in the last prop or last type within hybrid view is what platform you want to target. So in this case, the default is iOS, Swift, Kotlin.
Yeah, and maybe that also answers a question some people have asked before. Views can only be built in Swift and Kotlin. Maybe in the future there's gonna be, I don't know, maybe Java, and probably not, because I hate both of those languages. But maybe, I don't know, maybe we'll have something like this in the future, because on Windows you can build views in C++ and in C#. But on iOS and on Android, you have to understand. I think that's probably something that people have to understand first before looking at native code and before thinking about Nitro and Turbo Modules in general. Which language do I actually need, and which language is something available in? Because some people think using C++ automatically makes things faster. But then, you're still targeting like iOS, for example, and an API like current battery percentage is only available in Swift because it's built in Swift and Apple built it for Swift. So you cannot call it from C++, right? You can only go from C++ into Swift and then call it, which eliminates the purpose of writing it in C++ in the first place. So you can only build something in C++ when the API is actually natively implemented in C++, or only then it makes sense. So for example, for and iOS, this is not a black and white situation, because iOS has some APIs that are available from C++. I think core image, core video, GCD, and some others are available from C++. So those, or from C, because they're C APIs, like C, I think CV image or CI image or something like that is. Those are C APIs. But something like UI image, which is the default image type on iOS, is only available from Swift or Objective-C. And it does not make sense. It's not going to be faster if you use C++ to then create a UI image. It only makes sense if you have, for example, I think MMKV is the best example for this. MMKV, the original library by Tencent, is built in C++. They're using C++ APIs. They're using syscalls like memcopy or writing something to a file, and then they're modifying the buffers in memory. The encryption, the AES encryption is written in C++. All of that is written in C++. So they have one front end for C++, so you can use MMKV from C++. And then also they have a front end in Java, where what they do is they have a method, create MMKV, read from MMKV, whatever. And what they do is they just call the C++ method then. So if you use MMKV in Java, it's not a Java implementation. You're just going to call the C++ implementation. So it would not make sense to build React Native MMKV in Java, because it's going to end up in C++ anyways. And if you remember what I said before, the JavaScript runtime is C++. So the path would be JavaScript, C++, Java or Kotlin, and then C++ again to reach MMKV. So what you can do instead is you cut out Java or Kotlin and use C++ directly, which is what React Native MMKV does. So yeah, that's something you have to understand.
That's helpful.
Right. How are we time-wise?
We're good. I think once we wrap this up,
okay,
we'll be able to kind of go into our final segments here.
Okay, so views. We're going to generate that. Let's see if it works. Okay, so it is not out. Right, and Nitrogen is going to guide you always, right? So if something does not work, it's not just going to abort. It's going to tell you what you need to do. So in this case, we cannot generate a spec for red view because it is not auto-linked in nitro.json. It needs to be auto-linked because views, and this is what I said before, need to be connected to JavaScript differently than a normal hybrid object, because hybrid objects are just connected to JavaScript using JSI. So it's as low as you can realistically get without using Hermes APIs. But then for views, we create them differently because we need to inject them into the React Native rendering system, and the mounting layer fabric, they need to be able to create the views without touching JSI, right? Yeah. It's still JSI under the hood, but it's it's connected differently. Anyways, so we're going to go into our Nitro.json. This is going to become your best friend. And then we have red view, which is going to be implemented in Swift, hybrid red view. And I'm also gonna create a file now already. So hybrid_red_view.swift is gonna be class hybrid_red_view, and it's gonna implement this spec, right? Okay.
Yeah.
Same as hybrid math before. This is the same stuff I did now for the view, and I connected it in the Nitro JSON. Okay. So now that I did that, we're gonna generate specs again, and I think it's gonna fail because Kotlin. Yeah. We can ignore Kotlin for now. I can just give it whatever. Ignore is not a thing you can write there. I just called it that. So it's not going to build on Kotlin now because we also need to implement it on Kotlin, but
Yeah.
I'm just going to ignore that for now. Okay, so we added some files again. I need to do install again here. And then do pod install again. By the way, have you ever built an iOS app outside of React Native and used Cocoa Pods?
Sometimes, yeah, once.
I feel like once you've seen how fast Cocoa Pods should be, you're always super annoyed when React Native runs, because Cocoa Pod, like the normal way Cocoa Pod runs is you do pod install, and then when you press enter, it takes like 3 seconds or 2 seconds maximum, right? And then it's done. So yeah, people
14
often
seconds
blame.
is fine. I'll take the 14 seconds so I get hot reloading. That's fine for me.
That's true, yeah. That is fair. Right, so we have hybrid red view here. Okay, now we're gonna wait.
Appears.
Right, there we go. And we need to, okay, this is where Swift might be a bit confusing for people. When I fill this in, it's gonna try to type alias the view type, and I have to give it a type. Ignore that. So what you have to do is, should I explain that part? Maybe I can explain that part. Let's go to the definition of hybrid view in Nitro. The way hybrid view works is it's a protocol which has a view property, and you have to return a view here, or you have to hold a view here. And the type of the view is view type, which is a type inheriting from UI view. Associated types in Swift protocols, I recommend that you read them, because protocols are super, super cool. They're super powerful. It's more similar to Rust than most people think. At the end of the day, this just allows you to support inheritance for your view. So what you need to do is let view equals UI view. And now is red, let's do false. Right, and now it works. So the view part, again, it's not super important, but the reason, actually, let's do func something. So when I do view here, or self.view, I can see it's a UI view, right? Because I created a UI view. But if it's if I create a UI text view, for example, view is a UI text view. So that's what this protocol associated type thing does. Otherwise, if it wouldn't be an associated type, and if it would just be hard-coded to UI view, this would always be UI view, and I cannot do like text here, right?
Yeah.
So that's why this exists. So yeah, you have to create this property. This is what Nitro is going to render.
Do you want to take it back to a UI view?
Yeah, true. You're right. And then this is a property. Okay, so next step is, in our nitrogen generated folder, we can see something new here. We have shared, it's no longer C++ only, but we have JSON here as well. And what JSON, what the JSON folder contains is a view config for our Fabric view called red view. And as you can see, it has some, this is for React Native, so React Native can actually render this view. So we have stuff like supports raw text, events. We don't have any events in Nitro again. And then we have our valid attributes. So isRed is one of our properties. HybridRef is something I can show you later, but isRed is the property we defined. So this is the view config. And now is the part where it's a bit steep for newcomers. So what you do now is you create a new view component. It's a TSX component, and we're going to create the view, or we're going to make the view renderable, because this right here is only the type, right? This is only the type for the view. So now this is the equivalent of doing Nitro Modules.create hybrid object, but now for the Fabric rendering stuff. It's going to be, what is it called again? Sorry, it's not on Nitro Modules. It's Get host component probably. Yeah, I think get host component. The name is red view, and then the get view config is going to point to your JSON file. So from what is it? Nitrogen slash generated slash shared slash JSON slash red view config.json, and this is what you're going to return here. I agree that it's a bit tricky. It is mentioned in the docs, but it's probably going to get improved soon. We're thinking of how to improve it. Maybe we can move all of this to the native side. But I do think that React Native does some parsing on the views, so it needs to be JSON. So I think there's some optimization here. I'll need to look into that.
You're basically telling it what props and what properties it has that it can use. So, yeah.
This is also obviously something that a normal turbo modular fabric view also has. The only difference is that I think they generate this automatically for you.
So. Yeah, I believe Expo module does that automatically.
Yeah. Right. So this is something we're probably going to improve soon. Anyways, so we need to do types again. We need to do what is it? TSC, I think.
TSC.
Yeah. And then here, pun install, and then do pun install in a second. But what we can do in the meantime is we go into our app, and then we can do below our text, we can now render red view, which is hopefully going to be importable from here. Come on.
Loading.
Okay, anyways.
There we go.
Is it? No, it's not. Oh, I don't. Oh, my bad. I need to export red view. Actually, let me do that like this, so you can compare how it looks like. Right. So yeah.
Oh, that's a good point. Yeah.
Right. So these are the differences. Cool. So red view. I need to actually do that stuff again. I need to do.
You have an error on your red view file.
Where is that?
Really?
Oh yeah, you can ignore that. Bye. Let's see if that works now. Red view, there we go. Okay, so now red view is, and hybrid ref is missing. That's interesting. I thought this was not required. Wait, what? Oh yeah. Okay, I'm going to explain all of this in a second. Okay. Anyways, ignore this for now. We can render red view, and then if we run the app, we have red view here. Actually, let's make the view actually red. So what we're going to do is view background color red. And then we're going to give it a style, width of 40 and height of 40 as well. And let's run it. So that's going to take some time to build. Yeah.
Maybe you can explain the hybrid ref.
Yeah, good point. So, okay, to explain this a bit. A normal view in React Native has a ref, right? And let's see, for example, for text, you can pass a ref here. The ref contains stuff like, the ref contains stuff like stuff that every React Native view has. So you have stuff like focus or ID, stuff like that. So there's not a lot of text-specific stuff in there, but you can also add stuff in here. So text, for example, I think they added some stuff in here. I'm not sure which part. Probably blur, I think. I don't know. From an input or view. I don't know. Anyways, so this is a React Native thing, right? And then our view has some native state as well, which is different from the React Native stuff that they expose through the ref. So what we did, we created a new ref type called hybrid ref. Oops, I have it right here, which gives you access to the actual hybrid object. So as you can see here, this is the hybrid object again. This has the type, dispose, equals, and whatever. And you can also see isRed in here, and isRed is the Boolean. So this is the property that we set here. So this is the way to get access to the actual underlying hybrid object. And for example, if you want to pass, and this is what I do in Vision Camera, if you want to pass the preview view to your camera or other way around, you can use the hybrid ref for that or pass the camera as a prop here. But point is, hybrid ref gives you the hybrid object, and ref gives you the React Native handle to do stuff like blurring, measuring, and stuff like that. So those are two fundamentally different things. I think now that I'm explaining this, I think it makes sense for me to spend some time to investigate if I can merge it into one. Like if, for example, ref could be the hybrid object with methods from the ref as well. Like if it could be merged, but you have to remember that ref, or keep in mind that ref is something React Native built, and it also has a native state, and you cannot have two objects with native two native states in one object. So it needs to be, I don't know, maybe the prototype needs to be extended or whatever. Or we put, for example, we put the hybrid ref on the ref itself. So something like r.hybrid object, right? Or hybrid instance or whatever, which gives you the actual red view hybrid object. But right now that's the way it works. That's the way it works right now. Might change in the future again. Nitro views are a fairly new feature, and we've actually landed like 10 PRs or something in React Native Core to make this happen.
Oh, wow.
And yeah, so Nitro views are a bit different from regular views because we use a custom JSI prop parser, which I think most views on Android don't. Maybe they already do that, but at the time that we started working on it, Nitro views was the only, or we used JSI prop parsing using the Nitro prop parsing system, which means that all props are going to be parsed faster, which means that you can pass complex types in here. Like I can pass a camera instance here, for example, in Vision Camera v5 to a view. So it's going to be super powerful, but it's still evolving. Anyways, so yeah, we'll take a look at how we can maybe put it on the ref itself, but right now it is a ref. And then the callback stuff is something that's a bit cursed as well right now. So the maybe a bit as an explanation around the reason why this is why you have to do this. Every callback or every function you pass here. So for example, let's say we have on pressed or whatever, and this is a function. When you pass a function to a React Native view, it's going to register it in the event register bubbling event direct events system. And if you want to call it on a native site, there's no such thing as calling onPressed directly as a like self.onPressed, whatever. But instead you have to schedule the event call. So you have to say, okay, I want to emit the onPressed event, and then React Native is going to do that. But because Nitro passes functions as direct first-class citizens to your native view, this is not something what we want to do. We want to pass the function as is to the native Swift or Kotlin file. And React Native didn't support that, unfortunately. So we had to, and I think it does now because we created a PR for it, and Hanno did a lot of research there on my team. So yeah, super smart guy. He did some research on how it works in Fabric. He landed some PRs, and he actually made a React PR as well to support that. But now we're stuck with this because it would be a breaking change if I remove it now, right? So maybe I can add a way to handle both situations where if you, and sorry, maybe that part was missing. Callback, all the callback does is it takes a function and wraps it in an object with one key, and the key is F. And that's why I can parse it on a native side now, because it's no longer a function, but it's an object, and then I can parse the function. So it's just a trick around React. It works now in React. We can configure React to not do that, but then it would be a breaking change. So yeah,
makes sense.
I'll figure out a way to avoid that. So those are two things that we're going to improve. Anyways,
did our app build?
Oh, it's the same stuff from before again. I think I have some probably my bun setup is a bit weird. I'm going to just delete that again. Where was it? Here it is. Then kill that here, and then do that again. Okay. Actually, I don't need to probably. Let's see if I can just reload.
Probably just restart it as we did last time.
Yeah, right.
We should have some elevator music.
Yeah.
Finished before pod install? Is that why?
No, view config getter callback for command. I've seen that before. Received undefined.
No.
So the view config received undefined. Why did that happen? It includes that folder. Yes. That's a valid import, right? Yeah. I don't know. I can just fix it. I can just return it here directly, I think. Let's try that again. Oops. We have, this is, oops.
Another one.
Wait, what?
Is that an extra
I didn't
space?
save. No, it's not saving. Why is it not saving? It's loading some extension, right?
There you go.
Oh,
just saved. Took a while.
That's weird. Yeah, I don't know why that import couldn't be resolved. Let's just try again. I don't know what else to do. Oh no, it's that stuff again.
You have to do delete it.
Let's see if it's just, so I'm restarting Metro. With clean cache here right now. No, okay. Yeah.
It really doesn't like bun today.
No, it doesn't. Are you guys using bun for?
No, I'm using PMPM right now.
Yeah.
I know Jamin's a fan of bun, and I think he's been using it.
I've never tried PNPM, so I'm not sure if that's better. I think the reason I never tried it is because it's more letters than bun to type.
It's one more letter.
Yeah. Okay. Yeah. Looks like it just doesn't like me.
All right. Well, we're getting way over time here, and I appreciate everyone that's still listening. I think you have examples on your website on how to do this, right?
Yeah. No, I mean, React Native Nitro image is one view component that you can render, and then Vision Camera V5 uses view components as well. I'm just struggling with the Metro or bun setup here right now, but this would render as it is. Yeah.
And then, I mean, if we're talking about, that totally makes sense. Cool. Yeah, we don't have.
Just maybe one more feature for view components. You can also make your view recyclable. So if you do recycle.
That's important.
Wait, what? Why is it not? Oh, because it's not imported. My bad. There we go. Okay. If you make your view recyclable, you can handle view recycling, which is a Fabric feature, and it's super cool. And we use it for Nitro image, for example, to be able to render a lot of images in a list and then have them be reused. So if your view conforms to a recyclable view, it will automatically set up view recycling before rendering your views. And then in the prepare for recycle method, which is also, I think, called the same on Kotlin, you can reset your state internally. So for example, if you have an image view, I'm not going to go into detail how recycling works, but if you have an image view and a prop, like for example, URL source or whatever, and it's going to trigger. So once you set it, it's going to trigger a load, and that's going to take like a few seconds, and then set it on the UI view. It will obviously, so the reason that the thing that's going to happen if you don't have recycling is it's going to pull up old images, and they display a stale image, a previous image, and then set the new prop already, but it's still loading, right? So to prevent that, you would clean the image in prepare for recycling before the view gets reused, and then it can be reused again. So recyclable view. We also have methods called before update and after update, which are called, obviously before all props are updated and after all props are updated. We have some smart caching on the props to only parse them if they have changed. And we're also going to add children support soon, and what is it? Sorry, measure content.
Layout. Yeah.
Measure content. Yeah. Measure content from Yoga, so you can actually implement your own measurement system depending on props. So you could theoretically build a text component in Nitro.
Awesome.
Yeah.
Recycling views are very important for performance and many reasons, especially if you have many of them happening on the same screen. You definitely need to recycle them in some sort of way.
And also, if you don't need to do any recycling, for example, in our view right now, we don't need to do any recycling because every view is the same. It's red. You can just conform to recyclable view and not do anything in here, and it will support recycling now. But if you don't conform to recyclable view, it will assume that you don't support recycling.
Yeah.
So it's better to support that than to not support it, I guess.
Exactly.
But I didn't want to make it a default for everyone.
That's helpful. Yeah. Sometimes it's one view that's displayed once, and you don't need to do any of that. So.
And we do have that in the docs as well. So where is it? View components, and then recycling down here. Yeah, there's explanation for that.
Yeah, and the docs nitro.margello.com. I urge everyone to kind of take a look at them from there. Yeah. Awesome. So I'm going to stop sharing. Marc, thank you so much. This was great. And thank you to everyone that kind of stuck with us through it all. I like to do wrap up and takeaway before we kind of close out. Nitro is very powerful. There's many use cases for it. You put in a lot of work. We really appreciate all the work that you put in to help it be performant and kind of help get the goals within it. I think Gant asked the question at the beginning of the show that I wanted to save for this moment. What lessons from Nitro would you want the broader React Native community to take to heart? I think that's a very good question.
Oh, that's an interesting question. That's a very good question. There's a lot of lessons I learned in Nitro. First of all, I thought I knew C++ before I built Nitro. Now I did so much C++ and so many templates in Nitro that I finally know that I don't know C++. Yes. So one lesson is don't underestimate a language. And the most interesting thing to me, which probably some people don't really see as interesting at all, is how languages work. So for example, in Kotlin and in JS you have, or in Java, JVM for that matter, you have garbage collector, and it's a managed language. And then in C++ you do it yourself. In Swift you have ARC. It's super interesting to see how those languages work on their own, and then especially how they work when you try to mix them or cross language boundaries. Like how do you call from one language to another? How do you call from Swift to C++? Right now, I think there's 3 ways to do that. You can use the C++ direct interop, which is just directly calling a C++ method, which has a lot of limitations. You can use Objective-C dynamic dispatch and go through that. And you can also use called a C function, which hides the implementation in its body, and it just exposes a C, extern C function. And then the C++ stuff is limited because you cannot use templates, and the language C++ is so much more powerful that you cannot mirror all of its features into Swift. You cannot mirror templates into Swift because Swift requires something to be known at compile time that C++ evaluates at compile time. So that's one thing I learned, and I would recommend that every React Native engineer tries to learn some other language that just looks appealing to them. If it's C++, if it's Swift, if it's Kotlin, whatever, just try to do something with it. For example, back in the day, I wrote some tweaks using Objective-C for iOS, for jailbroken phones, right? so that's just super interesting to see how different stuff works in other languages and how important types are. That's also one other thing. I think many JS devs or TypeScript devs just aren't used to how types actually work. Types are in TypeScript, they're just slapped on and you cannot do anything with them. But in native languages, you can actually check, is something an instance of this interface, right? Whereas in JS, you have to just check if the property exists and then do a satisfies or any or whatever and just deal with it. But in native languages, it has to be a strongly defined type. And if two types look identical, they're not the same. You cannot pass them to each other, right? So those are obviously not some things I learned during the development of Nitro, but I would recommend that people who only know JavaScript kind of learn that as well, or take a look at native languages as well. What else? What other lessons?
I definitely would say do not slap any as a type. Don't use any.
Yeah.
Forget any exists.
I think this is the single most biased thing I can say with absolute confidence and no exceptions. If you ship something, if you ship a React Native app, it has to be fully in TypeScript.
Yeah.
There's no exceptions to it. You should not use JavaScript, and that also includes you should not use as in TypeScript, like as number, as object, whatever. That's also just ignoring types. And you should also not use any as a type. So if you want to ship something, always use TypeScript. Don't use JavaScript. It will blow up eventually if you do a refactor. So, okay, what else? Wait, one more lesson. I have one more lesson. I think React Native, Fabric, and Yoga are pretty cool tools. That's also one thing we learned in Nitro.
Oh, cool. Yeah, I think everyone should try out a native language if you haven't before. It's fun. It's different. I made the joke. The way to know if it's Kotlin versus Swift, Kotlin is fun while Swift is funk. So have fun with it. Do whatever you want with it. Before we close off, I want to do rapid fire. I've been doing these a lot recently, and I kind of want to carry this tradition going forward. Ask you a quick question, give me a quick answer, and we'll move on to the next one. What music or song do you like to play while you're coding?
Nothing. No songs, no music.
Quiet.
Absolute silence, yes.
Love it. Okay. What's your favorite recent movie or TV show?
Recent?
Yes.
Let me think. Avatar 3, I would say.
Nice.
Yeah.
Cool. What's one piece of advice you'd give to someone just starting out in React Native?
Ship as fast as possible, use TypeScript, read native code.
What are you most excited about in the tech world right now? Most. There's a lot happening.
I'm trying to think of something else than AI. Well,
we said at the beginning, Marc is AI, so yes, that's different.
I'm most excited about the Swift compiler and the stuff they're doing here with the C++ interrupt because it directly affects my work. What else? And then on a more macro scale, I would say AI, definitely.
Nice. Okay.
And one more thing, typed JavaScript. So as in what Hermes is doing with static Hermes.
Static Hermes, yeah.
Yeah.
All right. Last one. Where can people find you if they want to reach out? And how can the listeners be useful to you?
You can find me on X, on Twitter, under the name @mrousavy. And then also on GitHub, same name. Anywhere else? No. I guess Blue Sky, but I don't really use it at all. No. Everybody was super excited to switch from X to Blue Sky, and then in the end of the day, it was still just X is, king, I guess. Don't reach out for music advice, that's for sure. Yes, you're not gonna get some. I do listen to music, obviously. I don't listen to I do listen to music while I'm like driving or something, but not while I'm coding. For coding, I need absolute silence. We do have drifting. Yeah, when I'm drifting, then there's no music. It's too loud. But my devs in the office at the Marginal office, they sometimes also play music on the not play music, but on the put some music on, right? And it's mostly just like lo-fi chill music or something like this, or house, I guess. That's also fine. That still works, right? But I prefer absolute silence, but it's it's whatever. Yeah.
And how can our listeners be useful to you?
Give feedback. So even though my libraries have more downloads than ever, I for some reason hear less feedback from people, which hopefully means that it's working well and there's less bugs. Because back in the day, I received way more feedback. People just reached out to me, sent me messages or emails saying this doesn't work, this works. We have a community Discord as well. You can give feedback everywhere, even if something works great, and just show off your work, show what you did with our libraries or without our libraries. You can also just show off your work on our Discord and give us feedback. Just tell me, because I'm at the end of the day, it's what I'm interested in, right? Vision camera stuff. If you show me some cool frame processors and say, hey, I did that, or this does not work, or how can I make this faster? It's something that I'm interested in. So this is how people can be useful. This does not mean that I provide free consultancy, because some people kind of misunderstand that and ask me the simplest questions on vision camera, like how do I set up a QR code scanner, when there's docs that explain how to do that. So
Awesome. Cool. Well, I want to thank everyone in the audience that has been with us through this whole time. Thanks for sticking through to the end, asking your questions. It was awesome interacting with you all. Marc, thank you for coming on and giving us this demo. I really appreciate it. Thank you, Habibi. This was a fun episode.
Shukran. Thank you for having me.
And as always, listeners, please don't forget to subscribe. Reach out if you have any topic suggestions, anything you'd like me to cover in the future. I'd be more than happy to take a look at it. And have a good one. Bye, everyone.
Bye.